Hi, in my first video I showed overall visualizer interface functionality, and now I want to concentrate on temporal pooler details and show segment formation for all three phases of temporal pooling. And I relate this process to white paper pseudocode. Let's start by selecting sequence. So this is simple sequence square going back and forward. And to simplify temporal debugging, I skip spatial pooling and connect input space directly to temporal pooler. In menu here we have a skip spatial pooling flag. It's set on. And columns in region has just two layers. And because this is a simple sequence for demonstration, two layers is enough to learn and predict this sequence. A pattern in sequence always represented by four active columns related one-to-one to input space. So let's see temporal pooler learn predict the sequence in just a few steps. So, and after executing just 4 times, we have one-step prediction here. And after 8 cycles, we have 2 steps predictions. And if we run it for a while, we have multiple prediction learned for this sequence. And just after 40 cycles, we have maximum number of prediction for this sequence, 9. So let's see how it does it by selecting a particular cell and see how cell state changes over 3 phases of temporal pooling. Let's reset HTM state, apply first pattern, and select a cell to investigate this one. So now we click temporal split mode. This allows us to step through each phase instead of running all of them in one step. And you can see current phase here. Since we have active cells right here in the corner, I assume our selected cell will be selected as a best matching cell in a column when new segment update will be created for it according with highlighted pseudocode here. So let's see. We click on step, we execute phase 1 of temporal pooling, and now our selected cell has learning state, which means it was selected as the best matching cell here, and code from highlighted code from line 38 to line 41 was executed. So we set the learning state was set for selected cell, and we create a segment update, and that segment update is sequence segment. And if we look here, we see it. Let's click on this segment update in table, and with no surprise here, new distal synapses created for previously active cells. So if we click on them and go through, and the segment update segment attribute is new, which means there is no segment for it. The segment will be created from this segment update in phase 3. And distal synapses here were also just created. There is a new attribute here. Now let's click on step and we go to phase 2, and nothing happens here because if we look into phase 2 code, we need to have a segment, an active segment, to execute the code here, and there is no any segment for this selected cell at this point. If we click on step, we go to phase 3, and in phase 3, since our state, our cell in learning state, we will have line 56 and 57 executed, and we will execute adapt segment function, and our segment update will be used to create new segment, and segment update list will be cleared. So let's do that. We click on step, phase 3 executed, and segment update is gone, and we have new segment created from segment update. And we see segment distal synapses here migrated from segment update to our new segment. Now we're going through the same cycle, and we will see segment update creation in phase 1 and related segment distal synapse permanence positive updates from it in phase 3. The cycle will repeat itself until cell enters predictive state. So let's see, we remove temporal split mode to speed up the process, and click through the patterns until we approach our cell here, and now we click temporal split mode, execute phase 1, and in phase 1 we see segment update has been created, and the difference is that segment update now is created for existing segment. The segment attributes has a number index of segment it's linked to, and our synapses here were not new. We're just we're going to update existing synapses permanence. We go to phase 2, and nothing happens in phase 2 because even if we have a segment here, it's not active. The condition in line 44 is false. It's false because this segment is not active. The active attribute is not set for two reasons. First, the permanence for this segment synapses should be high enough to be connected. It's red, it's not, it hasn't reached connection point. And also, second condition, cells should be active, and we are not. So this condition is in line 44 is false, and nothing happened in phase 2. And now we execute phase 3 and see how segment updates will be applied to the segment, and permanence will increase. So we click on step, and yes, permanence will increase. We execute this code here. Adapt segment function and clear segment update list. So let's do it again. Phase 1, we create segment update. Nothing happens in phase 2, and in phase 3, segment update applied to our segment, and distal synapses permanence has been increased. And let's do it again. Phase 1, we create our segment update. Nothing happened in phase 2, and in phase 3 we have segment updates applied to segment, and permanence has been increased to the point of connection. So now permanence has reached connected point indicated by green color here, and as soon as cells here in the column becomes active, the segment will become active, and this will result in changing condition here, and phase 2 will be executed, and we will see this effect soon. So let's click through the step until cells here becomes active. Let's remove temporal split to speed up the process. Now we reach that point, and you see we have active cells and connected permanence. So this segment is active. It's active, and it's also connected to cells which in learn state. So two flags: active is set on and learning is set on. So now in phase 2 we will see two things. This condition is true, and our cell will be predicted, and we will see two segment updates created. So let's do. We click on step, and yes, segment update, segment is active, condition in line 44 is true, and our cell set to predictive states here in line 45, and in line 47 and 48 here we create segment update for segment with index 0, our sequence segment, and in line 50 to 52 we create new segment, this one, and this segment update will be used to create new segment for predicting this cell activation in 2 steps. So we click on it, and as you see, the synapse is connected to cells which were active 2 steps ago. So now let's go and to phase 3. Nothing happens in phase 3 because our cell in predictive state but not in the learning state. So, and now our state in learning state, and when we reach phase 3 the segment update will be adapted. And notice one thing: this code is not executed anymore because our cell is predicted, so we go to this part of algorithm. We just set to learning state, and but we're not doing any segment updates anymore. So we go to phase 3 next and see how this segment updates will be applied. Yes, and as a result our sequence segment permanence increased, and we create new segments which will predict cell activation in 2 steps here. So let's repeat that process again. Remove temporal split to speed up a process. Set temporal split, and so one thing for our sequence segment, we see the all cells is predicted, so it means they will be active in the next step. And let's see. Yes, they are active, and now our segment is active, and in next step we will execute phase 2 again. This code. So let's see. And because our segment is active, condition in 44, in line 44 is true. So we set our cell to predictive state, and again create 2 segments. This one, our sequence segment update, and our segment update for this segment. Again, we reach until cell enters learning state, and in phase 3 we apply segment updates which result in permanence, increasing permanence. So let's let's do this until permanence here will reach connection point. So just remove temporal split and go through. And now permanence here reach connection state. So let's see what's happened when segment 1 will become active. So first condition, permanence, we have enough permanence, we wait until cell become active. So let's do that. So let's go to temporal split and take notice the cells now in predicted state. It means in next step will become active and segments will be active. And here we are. So our segment is active. This means in phase 2 for this segment we will execute this code. And let's see. We go to phase 2, and yes, 2 segment updates were created. So in line 44, active segment condition is true for this segment, for segment 1, and our cell now set to predictive state. In line 45 here, it's predicted in 2 steps, and 2 segment updates again created, but this time for segment 1, and new segment update created, and this segment will be used to create new segment for predicting with this cell activation now in 3 steps. So let's go to next step, still in temporal split mode, and again now we have our sequence segments with index 0 active, and this means we will execute phase 2 for this segment. And so now we have new segments, new 2 segments added, segments update added for this cell. So line 44 condition for segments 0 sequence segment is true, and our cell set to predictive state, and we have 2 segments created. This one segment updates created in line 47 and 48, and segment 1 update created in line 50, 51, 52. So now we wait until the cell goes to predictive, learning state, and all these 4 updates will be applied. So let's see. It goes to learning state, and in phase 3, which will be next, we'll see it's all segments updates will be applied and will be cleared. And yes, so now we have 3 segments here. We have sequence segment, we have 2 steps segments and 3 steps segments. So now I'm going just to remove temporal split and click through the sequence And you see the pattern. So as soon as any segments becomes active, we see phase 2 kicked in for this segment, and we see segment updates start accumulating here. So for 2 steps activation segment, we have 2 updates, and we step again, and for our sequence segments we have another update. And now we have that segments with index 2 active, and this result in further back in time prediction. So now we will create segment update, which will result in creating new segments for predicting this cell activation in 4 steps. So, and whenever this cell will goes to learning state, we will see that new segment created here. So here we go, goes to learning state, and here we have our new segment created. So, and if we go through this process, it's just the same pattern. We just keep accumulating these segments. So, and we do this until we reach the maximum number of predictions here. And if you see our sequence segment has permanence, very high permanence, because it's been updating for quite some time. And if we go to other segments with farther back in time, we have less permanence. So, and when we run it, it will be learning until to a point when the permanence will become 1, and when learning will cease. So this is just all I want to show you about temporal pooling details. Thank you very much for watching. Bye.